I posted the original post on Reddit, I finally got around to making the video and posting it on YouTube. And so, without wasting any time, I'll get right into it. Okay, in front of me I have the device. Basically, it's a portable computer, and whatever you can use a computer for, you can probably use this for. Though it is running a Raspberry Pi Zero W, which doesn't have the best processor. It's basically a pretty low power, low spec mobile processor, and so probably won't be running anything crazy. Right now I'm demonstrating what is called a terminal. It's kind of how you would normally navigate around a computer, but in text form, just to give a slight definition. Not really the best one. Right now I ran a command called C matrix. All it really does is just bring in random letters and numbers to look like a matrix thing. It's just to make it look cool. It doesn't really do much. Okay, right there I had just opened up VNC Viewer. Basically it's a way for me to connect to my small computer from my desktop. Right now I'm picking up a Wi-Fi USB extender. Basically the board already has Wi-Fi installed, but I am unsure on how much range it can get. And so I just purchased this extender, which will ideally extend it a bit more. Alright, okay, now I'll be picking up this thing called the Google Coil USB Accelerator. It costs about 75 bucks, plus I guess tax and shipping, and it depends on where you get it from. And in essence, what it does is that it's a TPU, basically a sort of other processing unit that helps in machine learning capabilities. I'm unsure right now if it helps in training, but I do know it helps a lot in running your actual machine learning scripts or programs, right? If you have a facial detection software, it'll basically help this run at maybe 30 FPS. I know on a regular Raspberry Pi 3 or 4, it runs at 70, but this is a Pi Zero, so ideally I would hope to get around 30. I haven't properly tested it yet. On the back there are mounting screws for it. Basically there's 4 to hold it in place, and of course I plug in that white cable into the USB hub that then not only powers the Coral USB, but also allows it to send data. Right there is the camera. It's a basic, I believe it was a 5 megapixel camera, whatever Raspberry Pi uses. It's good enough. Here is the USB port, USB hub. There are 4 open ports, one of them is being used for the Bluetooth keyboard. Sadly, I wasn't able to make the whole system powered off one USB, micro USB. So there's like 3 batteries and 3 charging ports here, but I mean, it's fine in the end. The keyboard and the Node MC, which I'll describe later, doesn't need much power. Right here, I'm explaining I can mount that. There are holes there, which I would later on add a clip, which could then hold the USB dongle when it's not in use, meaning I would have to, I can carry it all together. Here is what is called the bad USB, or a rubber ducky. In essence, it's a USB that acts like a keyboard or keyboard inputs. Basically, I can write a program that will then do stuff automatically on the computer. You can do a malicious thing for it, but really I just use it to prank my friends. I would open up random links. Alright, here I'm just clicking the keyboard to give you guys an idea of how it sounds. I mean, if you own this keyboard or any Bluetooth small keyboard device, it would probably sound the same. I mean, it sounds fine. It's not like any mechanical keyboard, but it's usable. I will now begin the actual teardown of the device. It is held together by 4 screws. Not very hard to remove. Pretty easy to get inside if something breaks or you want to add on. There is a front plate to it, which I measured out specifically for this device and 3D printed it. That is the membrane, the black part, the membrane of the original keyboard. And looking inside, you will now see the rest of the parts. Up here is a 3000 milliamp battery. That is the 5 or 4 inch screen. I'll need to double check that by Hyperpixel. Behind it is the camera, which we'll talk about later. Right there is the Bluetooth keyboard. It is, I believe, a full-blown keyboard, so it has everything, you know, a 60% keyboard would have, and a bit more. Comes with a trackpad as well for the device. Alright, it's being held here by 2 screws on the side. This was, you know, it wasn't always like this. I had to add it in because I broke the original switch for it, but I actually prefer this one. It's a lot bigger and it's much easier to use. Right, taking the screws off will remove it. You can see here that there's electrical tape. That's to prevent any electronics from shorting. There's also the other battery I was mentioning, and also cardboard that is there to prevent it from being mushy and for it to be much more rigid when I am typing on it. Looking inside here, you see the rest of the electronics. There's a Node MCU I mentioned, also covered in electrical tape, the USB hub, and also a 900 milliamp battery with wires connecting everything. Alright, so before the top part can be removed, 4 screws need to be removed at the back. I'm also going to be removing the coil USB, which also takes another 4. And after all screws are removed, the front plate can finally be removed. Now I'm also removing the USB, the bad USB, and that just pops off. There's the camera I mentioned previously, the 3000 milliamp battery, the 4-inch hyperpixel screen, and also the Raspberry Pi Zero W with the GPIO pins connected to the screen. There's also the micro USB ports that are connected to either the USB hub or the Power Booster 1000, which is the little blue thing you see in the corner. That helps me recharge the battery properly. Again, 2 screws to remove it, and the front should just pop up, though it is connected with some of the lower parts, and those also have to come off. Most of the parts are either held by these little spacers or just a bit of tape, and just pressure down from the actual case will keep it all from moving. With that alone, you can now remove it. I will now explain a few things. The Node MCU is basically a small Arduino, has its limitations of course. Haven't really tested what it can do, since it's, I believe, either Bluetooth, maybe even Wi-Fi. I could probably do some IoT things with it, control some motors or whatever I needed to. I don't know, retract blinds, turn on things, I'm not sure yet. All I really use it for is to de-authenticate my siblings off the internet when I need the bandwidth for my games. Basically that means just kicking them off the internet consistently. Be careful with that. If you do decide to use it for that, use it at home, because it technically qualifies as a Wi-Fi jammer even though it's not, and you know, for legal issues it's not going to be taken well if you use it outside. Here's the other battery I mentioned, a 900 milliamp battery that just powers the Node MCU. It should be able to power it for a while. The USB hub is there, the Raspberry Pi Zero. I don't remember the specs of it, but I'll probably leave it on the screen. Of course, you see how everything is organized and put together. As for the bad USB or rubber ducky, it depends on whatever you call it, there are switches on the top which help me to pick whatever script I want. You can have 16 different iterations. Here is the case I printed. Basically everything is custom fit for these parts. Alright, I measured everything out. It took a lot of trial and error. There was like 4 different iterations for each part. Next video I'll probably cover the actual model of it. I'll fix some of the issues too, which I guess I couldn't cover today. And ideally by next video of this series, I will have the STL file ready, and the next video, or maybe in that same video, will have the electronics. As for the thickness of it, it's about 14 millimeters. Its height is about 120 millimeters, and its length is about 150 millimeters. It's a nice thing to hold, right? Everything, all the weight is equally distributed. I know someone mentioned the USB parts in a weird place, but as you can see, there wasn't much space to put stuff. But in the next iteration, I'll definitely fix that.